Let's talk about the rules of logarithms. So at the top of my page here, I have all the rules written out kind of in their fancy math form. And then below we'll do some examples that use them. All right, so the first two log rules that we have are the original inverse rules. So because b to the x and log base b of x are inverse functions, when we compose them in either direction, like you see here, what comes out is just the original input. So this first one is telling us b to the log base b of x always spits out x. So for example, this would tell me like 2 to the log base 2 of 9. I can't compute this kind of as is, right? Because log base 2 of 9 is not a nice number that I can figure out. But 2 to the log base 2 cancel because of this rule. And I can say, all right, this must be equal to the 9 because the 9 is the x in this example. They also cancel in the other order. So if we had instead log base 2 of 2 to the, I guess we'll reuse the 9, log base 2 of 2 to the 9. I say, oh, okay, I have a log base and an exponential base that match. So they're going to cancel, and this will come out to be just 9. Okay, so then after that, we have our three most commonly used log rules. So we have, if you have two logarithms with the same base that are added together, you can combine them into a single logarithm where their insides are multiplied. So adding on the outside would be multiplying on the inside. If there is subtraction between them, same thing, but it would be division on the inside. These two rules you can use in either direction. So some examples we see will give us a bunch of logarithms added and subtracted, and they say, okay, combine them all into one. We could also technically use it in the other direction, right? So if you have a logarithm with multiplication in it, let's say, you could break it up into the sum of smaller logarithms, and for some problems that might be helpful. The third one in this list of like regular log rules is if you have some logarithm with an exponential in it. So this looks a lot like the one at the top here, except for I have 3 different letters. So this base x does not have to match this base b, right? So here they had to match for them to totally cancel. But if like this is a 3 and this is a 7, we still have something we could do with that situation. So what we can do is take whatever the exponent is on that inside and take it out front as a multiple. So if this is, x to the 10th power, you'd have 10 times log of regular x. Let's just use that one in a quick example before we talk about the change of base rule. So if we have, let's say, log base 3 of 5 to the 7th power, right? So I'm choosing 3, 5, and 7, just 3 completely different numbers. They don't have to have any special relationship. This rule is telling me this 7, I could bring down out front as a multiple. So I could write this as 7 times log base 3 of 5. All right, the very last log rule is the one that in this class we're going to use the least, but I do want you to know it exists. It's called the change of base rule. And it says any logarithm, so just log base b of x, any random logarithm, nothing special. You can rewrite it as a fraction of 2 separate logarithms. And I put a little star in these spots because this can be any logarithm base as long as it's the same number in both spots. So these can both be log base 2, log base 2, log base 5, log base 5, or very often people use ln and ln for base e. But then the original inside is the top input. The original base is the bottom input, right? So this x is like physically higher in the original, so it's higher. The b is physically lower, so it's lower. Okay, so what this would mean, for example, is if you have log base 2 of 3, you could potentially write this. Let's pick any base that we want, right? So instead of base 2, let's do base e. So I'll use ln. This is the same as ln of 3 over ln of 2. You could also do it in the other direction. So for example, if you have log base 10 of 20 over log base 10 of 4, I don't know, we say, oh, okay, this is the ratio of two logs with the same base, so I can mush it together into a single log. So this would be log base 4 of 20. And if I had picked numbers that works together better, you might be able to actually compute this, whereas you couldn't before. But this one is not a nice number, so I'll leave it there. All right, so this change of base rule, we don't use very often, like I said. It used to be really important for entering logarithms in a calculator. So I'll show you in my calculator, I don't have, like when I hit a logarithm button, so I have just log or ln. So if I hit log, I'll come back to the screen here, it thinks base 10, like it's just a plain log, so the implied base is 10. So on a calculator like this, and not one of the newer, nicer ones, if I needed to compute something like log base 2 of 3, I would have to actually do something like this and do ln of 3 divided by ln of 2. And this number that it's giving me, this is log base 2 of 3. And if you have a nicer calculator or you want to pull up Desmos or something, you can double check that that log really is this number. So now that we have calculators that have more elaborate logarithm buttons, this isn't as necessary, but I do want you to know that rule exists. Okay, so let's do a couple of examples. The first one says simplify e to the ln of 2 plus ln of 3. There's more than one way to answer this question. What I'll do, since we're talking about log rules, is look at this exponent here and say, oh, well, ln of 2 plus ln of 3, this rule tells me I can combine them into the ln of 2 times 3. So this is e to the ln of 2 times 3 is 6. And then I have e to the ln of something, which is one of these, right? E and ln are the same base, so they're going to cancel. And what I get is just the 6 that was inside of the ln. Right? The next one asks me to simplify log base 2 of 4 to the x times 2 to the y. Because we have x and y in here, this one won't compute to a number at the end, but we can definitely write this kind of in a more simple way. There's a couple of different strategies you could take here. One thing that I would like to do, since I see this base 2 of the log and then a 4 and a 2 inside, I would love to be able to write this as log base 2 of 2 to the something, so that then I can use this rule here where the base is 2 and it cancels. So this 4 to the x, I could write as 2 squared to the x, which is 2 to the 2x, because you would multiply those exponents together. So I have log base 2 of 2 to the 2x times 2 to the y. And then exponent rules say we can add these exponents together. So we have log base 2 of 2 to the 2x plus y. And now I have what I wanted, log base 2 of 2 to the something. So log base 2 and 2 cancel. And what comes out is just that exponent 2x plus y. All right. The most common problem that we see using log rules is these last two that I'll cover in this video, which is they ask you to combine a bunch of logarithms into a single one. So notice in this first example, all three logarithms are base 10 because it's not there. So they can combine. And in the next one, all the logarithms are base E because they're ln, so they can combine. If you have, log base 2 and a log base 3, they're not combining. Okay, so in this first one, I'm going to use both of these log rules here, right? So if they're added with the same base, combine, multiplied. Subtracted with the same base, combine, but divide. So I'm going to do this one at a time. I'm going to take just the first two and combine them and just kind of go left to right until they're all together. So this will be log of x times y. And now I have log minus log. I can do top over bottom. So one single logarithm, xy over the x plus y from the second subtracted log. All right, this next one has even more going on because we don't just have ln minus ln plus ln. We have these numbers 2, 3, and a half out front. And these log rules only work if it's plain log plus or minus plain log. So we can't use those combining rules until we get rid of these numbers that are out front. And to do that, we're going to use this last log rule here. So we're going to use it in the other direction, right? So if I have a number out front, I can pull it back up as an exponent. So that's what I'm going to do in all three of these logs. So this first one becomes ln of x plus y squared, and then minus ln of x plus 1 cubed. And then finally plus ln of, so in here I have y to the 1/2 power. And I know the 1/2 power is the square root. So I could choose to write that as square root of y instead, or just leave it as y to the 1/2. Either way is fine. Okay, so now that I've done that first step, now I have what I want, right? So plain log minus plain log. So now I can go left to right and combine them using those regular rules. So these are subtracted, so I'm going to divide what they have inside into this new single logarithm. And now I have ln plus ln, so I'm going to combine them into a single log with their insides multiplied because it's addition here. So ln of x plus y squared over x plus 1 cubed times square root of y. You could also put the square root of y as part of the numerator. Either way, it's going to be correct, because if it's on its own outside here, it's really over 1. So it's part of the upstairs and not the downstairs. All right, so either one of these is a perfectly good final answer because I've combined all of this into ln of a single bunch of things.